Hey everyone, thank you for joining today. Today we are going to talk about an exploration we're doing over the summer. We have three interns that have joined us, and they are starting to look into something in Kubernetes called KRM Functions or KRM Function Spec. And we are curious about how we could explore using that for some commonality in some of the projects inside of Konveyor. So to start off, we'll do an introduction of the KRM Function Spec, kind of set the context of how this could be useful, what's involved. And then each one of the engineers has a different exploration area that they are targeting. And they're going to talk to you about the enhancements they have and how it kind of relates and what we're looking to accomplish by the end of the summer. So with that, I will kick it off. Jonah, Chaitanya, and Ankur, all yours.
All right. Just going to share my screen real quick. All right. Can everyone see my messy desktop?
Starting to. We're seeing two screens right now. Good. Got one and looks good.
Awesome. So hello, everybody. My name's Jonah Sussman. And here with me, I've got two other wonderful people. I'll let them introduce themselves.
Hey everyone, my name is Ankur.
Hello everyone, I'm Chaitanya.
And today we're just going to be talking about KRM functions, what they are, and just go in a little bit of detail on what our projects are. So here's the outline for the presentation. So we've got what exactly are KRM functions. You're probably like, what are KRM functions? So we're just going to explain that. We're going to explain how they could potentially be useful. So like, what do we have now, and how KRM functions could bring value to an organization. So to kick it off, I'm going to let Ankur start.
Yeah, hi everyone. So let's first define what KRM is. So KRM stands for Kubernetes Resource Model. So it's basically a way to state what you want to run in your cluster. So KRM allows you to express your desired state. This is a fancy name, but most of us might be using this on regular basis. And on the right-hand side of your screen, you can see few of the examples of KRM functions. KRM resources, sorry. Yeah. Now let's talk about functions. So functions are basically small and language-independent executable programs that are packaged as container images and that perform CRUD operation on KRM resources. So basically, in a nutshell, they transform KRM resources in a predefined manner as we define them in functions. And now let's see how the higher level execution of functions look like. So on the left-hand side of your screen, you can see an diagram where we have a function and then we provide it the input. So the input is the KRM resources and an additional optional function config, which contains the arguments or additional metadata that is required for the particular invocation of the function. And then we get the transformed resources back as part of output. And result is something that is emitted by function for observability and debugging. And on the right-hand side, you can see that we have chained two functions together. So it gives an idea that we can probably we can basically chain multiple functions together in a pipeline. Yeah, the KRM function specification. So KRM function specification basically defines a new object of kind resource list. And as the name suggests, it's a list of resources. And the functions which are there in Kubernetes, they basically take input as a resource list and produces an output also as a resource list. And we can pass the function config as part of resource list as well. And this KRM functions are already in use by the community with the help of KPT and Customize. Now I'll ask Jonah to explain it better with the examples.
Yeah, so what we've got is what I'm going to be showing is basically a simple KRM function example. So on the left, you can see that we've got a simple little Go file. I don't know if you can read that, but basically Right here, we're using the KPT Functions SDK. You don't have to use that if you don't want to, but you can. It has a bunch of useful resources when dealing with KRM functions. So on the left here, we've got this for loop that basically goes over all the items in that resource list that we talked about. And it's just going to be changing all these different tags to MySQL. So for an example, you might want to use this function if you're migrating an application and you're changing the name of, let's say, an object, and you want to have all the names go from name A to name B. Finally, at the end of this function, we're appending a results, just appending OK to say that everything went smoothly. So basically, in a nutshell, this example function takes every object in the resource list with kind deployment, you can see up here, and an API version apps v1, and it has its labels changed to MySQL. So let's see kind of what that would look like in a full pipeline. So here we've got that example function, and here are these two resources that we saw earlier. We've got this service and this deployment. First of all, if you want to use a KRM function, you have to put it into a resource list. So we put this into a resource list, and you can see this is a very simple resource list. It's just got kind resource list, items with the my service and Nginx deployment. It'd be too long if I tried to put everything there, so I just abbreviated it. And this is a simple KRM function, so we don't have any function config. So if you wanted to put a function config in this, you could. We're just not using that. So we put it into the input, fed through std in, get it through std out, and once you know it, it's changed. You can see over here, we've got these labels Nginx, Nginx, and it's changed it to MySQL, MySQL, MySQL. And if I had pasted the other thing, the service, you would have saw it would have been completely unchanged. So it only affected this deployment because it had the API version, apps v1, and kind deployment. And as you can see at the end, we've got this results with message OK, just to show that everything went OK. Success. If you're curious for more function examples, we've actually compiled a repository full of all these KRM function examples. Most of them, if not all of them, I think are using KPT, but you can check them out and just get a feel for what we've got going on. And so finally, I'm going to pass it off to Chaitanya to see, how this could possibly bring value to an organization.
Yeah, so first, let's see what do we have right now in both of the projects. So we have plugins which are written in Golang, and also we have Velero plugins which are written in Golang. So as we see, like both of the plugins have a similarity in their implementation. So if we take an example of a routes restore plugin, what we can see is like we have these annotations, and we check for the annotations. If the route is host generated, then we just strip the route from the cluster, and if it's not, then we just continue with the static route. So basically, the functionality between both of the plugins is quite similar, and we can see that it's a duplicate functionality overall. So what can we do using KRM functions? What we can do is we can use both of the adapter plugins, and we can generate a common library of KRM functions, which can be used across both of the plugins. And so there will be a common library which will promote code reuse and just allow for less time usage as compared to more development time, which is required right now. So let's see how KRM functions bring value to the organization, to the community, everywhere. So first we see that it follows a community standard. So KRM functions are open source. They are backed by Google. So they are also adapted by Customize. They work very well with KPT as well. So all these advantages are useful for the organization as well. The next is there are a lot of edge cases which can be across different applications. And what we can do is we can develop these edge cases and we can solve them using KRM functions. And we can use these functions in all of the given applications. So it is really helpful in solving all the edge cases across all of the applications. Third is it attracts vendors to Red Hat. So if we talk about Red Hat, if we talk about KRM functions, they are widely discussed in the community and is a hot topic right now. Google has recently open sourced it, and it is easier to integrate as well. And if I talk about the community, we can develop some KRM functions which can be used across multiple applications, where people can have a look at the repository and just make use of KRM functions which can bring value to their applications or their organization as well. The last is, as we already saw, it enables a greater code reuse, it removes duplicate work, and it improves the productivity of developers as well. So moving forward, we have our own enhancements for each of us, and we'll just present it ourselves. So I'll give it to Ankur to present his enhancement.
I'll share my screen. I hope everyone is able to see the presentation.
Yep, you can see.
Yeah. So we have just saw that what KRM function are. We got a little bit of background, how they work and how they bring value to an organization. So that is that. And now we want to utilize the KRM functions, and that's what my announcement is on, that how we can handle the executions of KRM functions. So the problem is that let's say we have KRM function and everything is there, but how do we use them in our own products? So to leverage the benefits of KRM functions in the Crane, we need some way to handle the KRM function execution. And at present, the Crane do not possess the capability to handle or run KRM functions. So the solution, one of the solution is we will be adding a subcommand in the Crane command line interface that can run KRM function and with the arguments. So this is the general synopsis which we are proposing to have. So this will the command will look something like this, and this command will be used for transforming resources in the export directory, which is created by the Crane export subcommand that is already there, and will use the resources from that and transform using the function. So it will transform the resources with the use of a containerized image, which we containerized image that is function. So that will look something like this. And then the function which we are invoking can take arguments from outside. So let's say you want to set labels for all your resources. So you can provide the labels as part of the arguments, that what kind of label you want to add it to. And then we have some limited flags as of now. So this is in semantic with the Crane command, which we already have. So the export directory is the directory where the resources are there, the raw resources are there, in which we want to transform. And the transform directory will be the resources where the transform resources will be there once it is executed, the function. And environment provides the list of environment variables which we want to export to the container. So there was one alternative solution we thought of. So the alternative solution was to use the already existing solutions like KPT and customize to run functions. So if we are using that, the scenario will be something like that. To utilize functions in Crane, we'll first have to export the resources using Crane export. Then we'll transform the resources with KPT or customize and store them in a transform directory. And finally, to apply them to a target cluster, we need to apply it using the kubectl apply. So for a single task, we'll have to utilize 3 different utilities. That was one of the things for which we have not yet gone with this. And this approach is not entirely rejected yet, and this could come into play in the future. But for now, we would like to know how the function execution integral to Crane would work. And it also gave us the flexibility to customize how we want to handle the function execution. I have created a small demo of what about the similar work. I'll just play it for you. So as we can see, the function help command will have this particular synopsis, and these are the arguments which I explained earlier, and these are the flags which will be available. And here you can see some examples of how to apply function and how it will look like. So this command also by default take the transform directory as transform and export directory as export if not provided explicitly. And here are some of the images which I have created. These are the function I created on my own. So I'll test them on one of the example resource. So here you can see I'm going to transform this metadata. It has a lot of unnecessary field for it applying to the next cluster. So I'll apply that function and remove that. Yeah, so a test data is the directory where my resource is present, and this is the clean metadata is the image which I want to apply. And here you can see that that function is applied and this test transform directory is created where the transformed resources are present. And I'll show you that what happened to them. So now you can see that the metadata is changed and it is clean, and this is what we want. So this is just an example demo, and it can have a lot more it can do a lot more complicated stuff than that. Okay. So these are some references, like here you can find my enhancement pull request, and for the in-depth enhancement doc, what I have been proposing, and this is the link to my demo which I have created. And that's thank you. If you guys have any question, please feel free to ask.
Great, thanks, Ankur. And I'll just pause for a few seconds to see before we go to the next enhancements. Anybody have any immediate questions for Ankur? Cool. All right, let's move on.
Thank
you. Yeah, so I'll continue. Okay, can you see my screen?
Yep, looks good.
Yeah, okay. So yeah, so my enhancement is about adding KRM functions to current Velero OpenShift plugin code. So yeah, so initially the motivation behind this is to have a common set of KRM functions which are reusable. So as Ankur already mentioned, we are planning to create a shared library across OpenShift, Velero plugins and Crane plugins to improve code reuse and productivity. And the enhancement particular to this, the motivation particular to this enhancement is like we are planning to improvise the Velero plugin framework. So to improvise the framework, we plan to introduce a new plugin type that will allow Velero to leverage KRM functions for resource transformation and item gathering. So we can improve the plugin performance by processing n items with a single gRPC call. So currently what happens in Velero is there are n gRPC calls for n resource transformations, and we plan to pass in a resource list so that we can just allow it to make one gRPC call for all of the given resource transformations. So the particular goal of this enhancement is initially you have to check and research if the given approach is feasible, because there are a lot of things moving around Velero, and we need to check if KRM functions can be executed smoothly with current Velero plugins which we have. Then secondly, as I already mentioned in the motivation, we plan to introduce new plugin types, which are backup items, KRM backup items and KRM restore items, which will accept a resource list as compared to a single resource which it accepts currently. And the third thing is we need to modify our Velero fork to enable new plugin type and will all pass in a resource list so that we are able to process multiple items at a time and ultimately improve the performance of the Velero backup restore process. So yeah, moving on to the design and implementation of the enhancement. So we have divided this into 3 phases. The phase 1 will be research, and it will consist of modifying the current OpenShift plugins to add KRM function logic and transform the resources as it is. This might add a bit of overhead right now to the current plugins, but we plan to improve this by adding new plugin types, and that will be the phase 2 of the enhancement. And the phase 3 will be modifying the Velero controller code base so that we can pass in a resource list as compared to a single resource. So this is the phase 1 that will look like this. So what Velero does is it has an input and output parameter right now. So in the input, it will get a single resource, and we'll add a KRM function logic to transform a particular resource. And we'll just convert the input object to cube object, which is used in KRM functions SDK to transform the resource, and will initially get the output for the Velero. Improvising on this, phase 2 will be development of two new plugins, which is backup items with KRM and restore items with KRM. And I have just referenced the code in case anyone has to have a look at how the plugin types look like currently in Velero. And what will it do is it will return a list of items with translated data to be included in the backup. Lastly, phase 3 will look like this. Again, I have included a reference to Velero controller code where we will make the changes to modify it to pass in a resource list so that we can achieve performance enhancement by reducing the amount of plugin calls to the current OpenShift plugins. So there are some drawbacks right now for all of the design and implementation part, which I mentioned already. So as I mentioned, so currently if we add a new Velero plugin type, it will require a significant overhaul of Velero server framework, and it will require a lot of discussion with the upstream community. So this will likely take a lot of time. Then we also have to rewrite the Velero controller in all of the given phases and the process, and this will take some time and efforts as well. And the last thing is, if we move on to the phase 1, processing current items with KRM functions within the existing plugins will slightly reduce the performance. And like if we need this to be a long-term success, we definitely need to complete phase 2 and phase 3, which will improvise the performance of the Velero process and drastically improve the process as well. So if you have any questions, I'm open to answer them.
Cool. Thank you, Chaitanya. Any questions before we move on? All right, Jonah, I think it's all you.
All right, so I'm just going to be talking about my enhancement. So let's see, let me make this bigger. So when talking about KRM functions, there's really no standardized way to manage the versions of these functions. So when you install, let's say, a function foo or a function bar, and you install or you reference version 3 of foo and version 4 of bar, and an update comes out, you have to manually go in and change each version. So what my enhancement does is it proposes a tool called Caffeine. Really proud of that name, but it can be subject to change, to help manage the discovery, installation, removal, and updating of KRM functions. So basically, it sort of acts like a DNF or a YUM or an NPM. So in terms of motivation, there are multiple different ways you can solve this versioning problem. So one way is you can just reference the tag latest when you're doing the image of the function. But this leads to a lot of different problems. For instance, I have 3 listed here: lack of reproducibility. So whenever you reference the latest on your development machine, it grabs, the standard is that it grabs the image, installs it, and then that's it. It doesn't check for any updates. So when you install it on a different machine, while you might have V1, V2 might come out, and then it has some breaking changes. Also, security vulnerabilities when you do this. Many enterprises will just simply, they won't tolerate updating to the specific latest version that's out. They want to vet processes and have things to make sure that, okay, this doesn't cause any obvious security holes, log-J5 style. And then finally, it's dependent on container technology. So KRM functions utilize container technologies for now, but Customize actually has the option to use regular raw binaries as KRM functions, and they're trying to get that into the spec. So relying on these tags just won't work for that. Another option is you could just lock down the functions instance to a specific version. So, but this has its own set of problems. It doesn't have any version mobility. I mean, you have to go through each individual reference and update it on your own. Also, there's still security vulnerabilities, because what if you have version 1 and then version 2 comes out and version 1 turns out to have a security hole? You have to now go in and update, and then you have tech debt. And then finally, auditability. So if all your functions are defined in one place as opposed to scattered around, you don't accidentally use 2 different versions. You can just have one version and know that's your issue. So what this does is, what I'm proposing is a tool called Caffeine to help rectify these issues. Much like how you can technically manage your system packages using dpkg, I'm sure nobody does that. If you do, please talk to me. I want to know what kind of caffeine you put in your coffee. But usually you let apt or DNF manage these installations. So a few goals for Caffeine is that you should be able to add or remove catalogs of KRM functions. I think that's a pretty standard goal when you're using a package manager. Is you want to be able to add a catalog and search this catalog for functions to be able to say, okay, is there any updates? Similarly, that second bullet point, you want to be able to search these catalogs for functions and install them, right? Discoverability, I didn't get into that in the motivation, but also discoverability is another issue. If you have this fantastic KRM function, there's a KPT function centralized repository, but there's really no anything other than that. If you want to have a function that has a specific functionality, searching for them is really unergonomic. And so hopefully this tool will be able to help rectify that. Also, easily update the functions. I think that ties in with searching and updating. And finally, you should be able to easily opt in or opt out of the system. If you want to use Caffeine, great. But if you already have a project that's not using Caffeine, you should be able to opt in. And then if you find out Caffeine's not for you, you should be able to take everything that Caffeine has and be able to opt out. Some non-goals would be running the KRM functions themselves. So that's based on the consumer. That's the consumer of the functions, not not Caffeine itself. And then finally, managing how the applications actually use those functions. Again, that's totally on the consumer of the function. So for those of you who are curious, the main technology that Caffeine uses is called a function catalog. It's actually here in KEP 2906. But basically, it's a YAML file consisting of a bunch of KRM functions and the associated versions, and actually have an an example down here. We'll get into that. But an example workflow of using Caffeine would be, okay, first, I've got a catalog of functions that I know I want to query or have be updatable, or have my functions referenced to be updatable. So we add that config to the catalog. So the catalog is then appended to its known catalogs in a certain way. I'm sure you can check this out for the specifics. Next, you can search a catalog for a specific name of a function. So using Caffeine search. And then finally, once you find a function that you want to install, just install it using Caffeine install, and it will be added to the list of known functions that it installs. And then finally, the real magic sauce, if you want to update your functions, just execute Caffeine update. It'll check all the catalogs for any new versions. And then once it gets those new versions, it checks the versions in the catalog with ones that you've installed. So here's a user story. So let's say we've got this catalog. I don't expect you to completely read this and digest it, but the highlights are that we've got a bunch of KRM functions in this list, and then a bunch of different versions within each KRM function. So you can see this KRM function named Java application has two versions, version 2 and version 1, each with their own containers. We've got Logger with three versions, version 1.0, 1.01, and 1.02. And then this secret sidecar, which only has one version, version 3. So Alice wants to has some in mind some functions that she wants to create, some functions that she wants to use. So first, she searches all the catalogs, and you can see these three functions right here. And then she says, okay, I want to install Java application and Logger. And so it does it. And then Caffeine list just lists the names of the functions that are installed. You can see we've got these two that are installed. And then we can also output it in YAML so that it can be passed on to a different application. They can use these functions that are installed. You can already update an existing application using Caffeine. So here we've got these applications. We've got these functions, sorry, Java application 1, Logger 1, secret sidecar 3. So we can check for updates and then update the specific ones that we want. And then what do you know? It's updated. Here's some just name conflict stuff. And here are the actual CLI commands. So we've got search. You can see some examples over here. List, install, remove, update, config. And then some drawbacks with this tool. So this tool seems great, at least in my opinion. I mean, of course, I'm working on it. It seems great so that you can install these specific versions and have something else manage it. But a drawback would be that introducing another tool into your workflow could cause some unnecessary complexity in simple projects. So if you're just using KRM functions for dev tools or something that like you've got like maybe like 3 KRM functions, introducing a manager for this might just cause unnecessary complexity, and you might not want to use this. But for larger projects, definitely a manager would definitely be needed. And so the overall goal of Caffeine is that you've got a bunch of catalogs. You take these catalogs, add them so that your local Caffeine installation knows about them, find some functions that you want, install them, and then later, when new updates are pushed to these catalogs, just add an update. It's as simple as that. And then, yeah, that's basically it. If you have any questions, please feel free to shoot.
Cool. Thanks, Jonah. Anyone have any questions for any of the topics that we discussed? All right. Well, thanks, everyone. I will end the recording and I'll get this posted.